Hello guys, so today we are going to learn Chroma DB. Okay, so it is a vector database. We are using generative AI in LangChain and LangGraph. So Chroma is a AI native open source vector database focused on developer productivity and happiness. Chroma is licensed under Apache 2.0. Okay, so this is the Chroma DB. Okay, here we can also search. Okay, so this is the Olama. What is Chroma? Chroma DB. So Chroma DB is an open source high performance vector database designed for machine learning application, particularly large language model. It store manage vector embedding. Okay, so we need to store embedding. So where should I store it? So we have vector database, which vector database. And it manages a vector embedding, which are numerical representation of the complex data. Like if you have a complex data in images, audio, oh, in images, audio, video. So we need to create its vector. This will store in a vector database. These data like Chroma DB fast and efficient semantic search, making it ideal for applications such as semantic search, recommendation system, retrieval augmentation generation, and AI powered chatbot. So we use Chroma DB different. Uh, okay, here are the key features and capabilities. This is the vector embedding. Chroma DB specializes in storing and managing vector embedding, which are a numerical representation of data. Okay, so vector embedding is numerical representation of the data that AI model used to understand relationship and meanings. Okay, semantic search, it facilitates semantic search by allowing user to find a data point that are similar in meaning rather than just matching keywords. Okay, so semantic search, we are like if we need to store embeddings in a vector database, and semantic search means we are going to find out similar meaning rather than matching a keywords. And scalability and ease of use. Chroma DB is designed to be scalable, handle and large volume of the data. And here integration with ML framework. So it integrates with popular machine learning framework like LangChain, PyTorch, and TensorFlow. Okay, so open source project, it is available under Apache 2.0 license for the commercial use. Okay, so this is the application semantic search and document search, recommendation system, AI with chatbots, image retrieval and classification, retrieval augmentation generation for LLM. Okay, how it is work? So embed creation, complex data, text, images, etc. is converted into a numeric embedding vectors. Okay, if you have complex data, we need to create embedding and store it in a vector DB. So here you can see store at point 2, store DB, Chroma DB store the vector embedding along with the associated metadata. Querying, when user asks the when a query is made, user asks the question from LLM. So then Chroma DB convert the query into a vector and perform fast similarity search to find the most relevant embedding and their corresponding data. Okay, so how it is work? So in 3 steps, Chroma DB worked. Okay, so after that I need to teach you. This is the documentation of the Chroma doc.try chroma.com. Okay, here you can see this is the official page of Chroma. Okay, so we are going to use chunk and chunk overlapping in this tutorial. So we need to know about what is chunk size. Okay, so like if you have full context in PDF like this, okay, and we need to create its chunk like and chunk divided in context 1, context 2, and context 3. Okay, now we need to do overlap this. Okay, so content 1, okay, and content 2 and content 3. Content 2 overlap in the half or middle and after middle of the content 1. this will overlap. And here you can see content 3 also overlap from content 2. So chunk size refer to the maximum number of the character or token allowed in a single chunk. Maximum number of the character or tokens. Okay, allow in a single chunks. For example, if the chunk size is 300, each chunk will have up to 300 characters. Okay, imagine for example, chunking is a process of breaking a large piece of text into a smaller piece to make it easier to process and analyze. Like if the chunk size is 40, like we have size equals to 40, character size is 40. So here this is the chunk one. Chunking is the process of breaking a large piece into a smaller manageable piece to make it easier to process and analyze. Okay, so this is the chunk 1, chunk 2, chunk 3 and chunk 4. Okay, you can use a tool count of the tokenizer, or you can use TikTok token like that. Okay, so this is the code for this. We will see how to do chunking in our code by applying vector database. Here what is the chunk overlap? So chunk overlap refer to the number of character or token shared between consecutive chunks. So overlapping ensure that inputted context is not lost while dividing the text into smaller part. Okay. So here you can see example. You can understand by using example. So chunk size is 40 and overlap of 10. Okay. So like if we have 40 word in line like this is the suppose this is the chunk size. Chunk size. I mean this is the line which have a chunk size of 40. Suppose. Now we need to overlap this. So we start next line from this, okay, and there is another content. So this called a chunk overlap. So chunking is a process of breaking up. So here breaking up, this is overlap here. Breaking up and next chunk. Next chunk, breaking up is overlap here and start from large piece of the text into. So here this also overlap here text into manageable piece and this line start from the piece, make it easier to process and analyze it. Okay, so breaking A is part of both chunk and chunk 2, ensuring that no context is lost between chunk. Okay, so now I'm going to move my documents. Okay, so here this is the file I'm going to write code here. So these are the libraries. This is the Chroma DB. We are going to import from LangChain underscore Chroma, import Chroma DB. Okay, so we need to store our vectors, and this is the text loader. We need to load our text from LangChain underscore community dot document loader. Okay, and this is LangChain community dot embedding import Olama embedding. Here I'm going to use Olama embedding. This is open source. Olama is open source model, and open source platform. Olama has lots of model. So according to your need, you can use model. They have different models for text, multi models for voice, and they also have embedding models. Okay, from LangChain text splitter, we are going to import character text splitter, recursive character text splitter. Okay, so uh, here I am going to loader equals to text loader, and I am going to load my document speech dot text. Okay, this one. In here data equals to loader dot load Now I'm going to check our data. So I'm going to run this. So this is our data, and we load our file in text format by using text loader from LangChain. Okay, from this text loader. Okay, so this is the metadata source. Source is speech.text, and this is the page content. Okay, the world must be made safe for democracy, etc., etc. Okay, now I need to splits. Okay, so here text dot splitter equals to recursive character text splitter. Here I am going to pass chunk size. Chunk size I already defined. Chunk size. Oh, chunk size equals to 500, comma chunk overlap 0. Okay. Now I want to split. So here splits equals to text splitter dot split documents. Here I am going to pass data recursive object not have split. Okay, so split equals to text splitter dot, oh, here I did mistake, split dot documents. Okay, after splitting and different parts, I need to if you want to check splits, you can run here splits. Okay, so it is split document in different documents or chunks, in different chunks. After that, I need to create after splitting I need to create embedding. So here embedding equals to Olama embedding. Okay, so I'm going to use Olama embeddings and model equals to I want to use model equals to you can use any of model from Olama, but I'm going to use mini LM. Okay, all mini LM. Here I'm going to store vectorDB equals to chromadb. No, it's a chroma. Okay, chroma dot from document now document equals to splits and embedding equals to embedding. Okay, here I need to check what is in vector DB. Okay, so here this will take some time, so we can check Olama. Okay, so this is the Olama, guys. We are going to use Olama embedding, then you need to download it. Okay, here you need to click on this button, then you got exe file. Okay, and like this this one. So this is the olama setup.exe file, and you need to install this. Click, and after that you need to finish it. And after installing olama, you have one symbol here. This is the olama, okay, and you want to like, I mean, you need to open it in command prompt. So you need to run here olama, and you can check olama list like this. And if you want to pull any model, so here you can write olama pull all min lm. Okay, so I'm going to use this model. So I have used olama pull all hyphen mini lm. Okay, then you can use it in your code. And okay, so I'm telling you. Okay, so olama is a free open source tool that simplifies running large language directly on your local computer. Okay, so you can run a large language model directly in your computer, offering greater data privacy, security, and control compared to the cloud-based solution. Okay, we can interact with the various open source like llama llm like llama 3 mistral without requiring complex coding or cloud dependency. Okay, and here you can see these are the models. Okay, we can use, if you install olama, then you can use these models free. Okay, these are the model for text processing, image processing, video, audio, multimodal. So Mistral, Code Geeks, DeepSeek, OpenChat. Yeah, these are the model you can use. Okay, these are the library of olama. Okay, and now I want to ask the query. So here query equals to query equals to okay. So this is the query from the document. What does the speech I believe in is the main reason the United States should enter the war. Okay. So here I'm going to create doc variable. Docs equals to vector db dot similarity search. Okay. Here this is the similarity search, and here I'm going to pass query. Okay. And now I need to check docs and zero docs dot page content. So here we can see page content of document 1. Okay, so you can see here this is the page content of document 1. Okay, so this is the query, and we ask this query, and this will match the query in vector database and generate the response. Okay, and I need to save this. save this vector db. Vector db equals to chroma dot from documents. Here I'm going to pass documents splits, comma, embedding, embedding equals to embedding, comma, directly where I need to save this. Okay, so persist directory equals to dot chroma underscore db. And after this I'm going to load. Okay, so here load equals to no load equals to not load equals to, so here db, oh getting error, invalid argument. We need to check vector db chroma vector db chroma dot from documents equals to splits, embedding equals to embedding, and persist directory equals to chroma db. Okay, uh, 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 so here uh, so here I am going to import, I have imported subtil. Okay, so it permanently delete. Okay, delete if you have any chroma DB folder here. Okay, so this is I'm going to I'm creating this by using this query. Okay, so here create a persistent client. Okay, so where do you want to keep it? Then you need to give a directory. This is the folder name here. Okay, so create a collection with the explicit dimension. Okay, so here I am going to create a collection. Okay, this is a persistent client, and this is a create collection. Here my collection name is my name equals to my collection, and this is the metadata. Now initializing embedding again. Okay, so this model are very small, has very small dimension, like I mean it has a approx 384 dimensions. Okay, so we are getting rid because our document is large. So here that's why we need to create collection here. Okay, and this is our embedding, and this is our vector db uh, client, persist client, collection name, my document, and embedding equals to embedding. And here okay, and this is the again I'm going, sorry, now add the documents here, and this is the query I'm going to ask, and this is the similarity search, give the similar meaning, and print the page content, or also save the model here in this directory. Okay, now we don't need this. Okay, so after that Okay, so this is the similarity search. If you want it, if you want to search query equals to vector db, this one doc equals to vector db similarity search. Okay, this is the query. Now you got the answer from this mm, this document is split. So why this is the vector database? Like if you have documents and text, okay. So this is the library we have imported from LangChain, okay, and uh, the this is the code for uploading documents, and we are going to use splitter recursive character text splitter to split the document like this, okay. Then we need to create a embedding, so I am using Olama embedding LM, and this is stored in a vector database, and after that we need to query it, and here we are going to save this vector db, and again we are going to query from this vector db. Okay, I'm going to write doc equals to doc equals to vector db dot similarity search dot similarity search underscore with relevance score. Similarity search by image with relevance score. Similarity search by vector. Similarity search with score with relevance score. Okay, so I'm going to use this similarity search with relevance score. I'm going to pass a query. I need to run this. So now one. Okay, so this is the documents. This is the ID of documents. 1, 2, 3, 4, 5. 5 documents are showing here. This is the metadata. This is the document name. Source equals to document name. This is the page content. Okay. So this will generate the query. Similarity with the relevant score. Okay. Okay guys, bye bye. See you in next video.